Correct. We divide anything to make that thing easy. After that, we had
Easy
seen
manageable.
all the layers. And see, after application layer, I can directly jump to transport layer now. Application, because we are not going to discuss about presentation and session. So application, then transport. At application layer, what is application layer? Tell me some services of application layers.
This is the last
HTTP,
layer.
HTTPS,
Not
DNS.
last layer.
Communication.
This is not last layer. It can be first layer on sender device and it can be last layer on receiver device. So
Yes.
application layer can be layer 1 or it can be layer 7, depends on the device, like on which device we are talking about. If I will talk on the sender device, it will be layer 1. So there was some services like web access. Web access, and what was the protocol to access this service?
Port
HTTP.
number.
HTTPS,
Correct.
Yes.
Correct.
HTTP and
HTTP.
HTTPS.
Correct. HTTP and HTTPS. There are only two protocols to access the web page. Then there was one another service, remote access service. What was the protocol to use this service?
Telnet,
Telnet and
SSH.
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 SSH and Telnet.
Correct, correct, correct. Then there was service called IP configuration.
DHCP,
Protocol
DHCP,
DHCP. File share, file sharing,
FTP.
TFTP and
FTP.
FTP.
and some more services was there. Okay, for now leave it. So we have some protocols like HTTP, HTTPS, Telnet, SSH, FTP, DHCP, then
POP3, SMTP,
mail
IMAP.
service, POP3,
DNS.
DNS, very good, right? In the service you can say
DNS.
service.
IMAP.
SMTP.
Service is resolving domain name into IP address, and the
IP
protocol
address.
is
DNS.
DHCP. So for each kind of service we have protocol, and how we identify this protocol at transport layer?
Using port number.
Yes, we identify these protocols at transport layer with the help of
Port numbers.
port numbers, right? So at transport layer, first of all, we had discussed port number. What is port number? Unique identity of application layer protocols, right? What is the length of port number and how we represent it?
16-bit
That is
decimal.
16 bits decimal value. So range is going to be what?
0 to 65,535.
0 to
34.
65534.
4.
Right, and this range is divided into two parts, well known and unknown. These ports are divided into two parts, well known and unknown. Well known ports are those ports which are already assigned to protocols. Yes or no? Tell me guys, because this is what we have
Yes.
already covered.
Yes,
Yes.
yes, well known and known.
Right, second one is unknown, which are free. We can use at
Free for further
source,
use.
which we
future use.
can use at source. What is the
Sorry to interrupt. So what we're doing is a recap from yesterday because I was not able to join the class yesterday.
yes, right now I am recapping yesterday. What was the primary function of transport layer? Adding port number with actual data, right? And to add this port number, we have how many protocols at transport layer? Two.
TCP and UDP.
TCP and
TCP
UDP.
and UDP. Either I can add source port, destination port by using TCP protocol or by using UDP protocol. And your machine already know that if this is HTTP protocol, at application layer, if protocol is HTTP, then a transport layer protocol is going to be TCP. If application layer protocol is DHCP, then transport layer protocol is going to be UDP. Right? Your operating system has already this configuration. They already know that what protocol should I use. If you will use TCP, then TCP is going to add TCP header. UDP is going to add their UDP header, and we'll see both the headers. If I will show you here, you can see some important port numbers and services, right, at transport layer, like port number 20 and 21 used by FTP protocol, and transport layer service is TCP. See, about all the application layer protocol, how you will learn few things like application layer protocol. This is packet flow, application layer protocols. So first thing which you need to learn is what is the function of that protocol. Second thing, right, you can ask this question, like if you are learning HTTP, so what is the function of HTTP? Accessing web page. Second thing, what port number that protocol is using. Third thing, what protocol call is used at transport layer, right? So I want you guys to understand these three things about all application layer protocols, all important networking application layer protocols like HTTP, HTTPS, Telnet, SSH, TFTP, FTP, DHCP, DNS, and some more protocols are there like BGP. We will talk about that later. Okay, so what is the function, what is the port number, and what service at transport layer. Done. So you can see here the port number, service means protocol, and service at transport layer, like protocol at transport layer. Then transport layer, this layer provides reliable and unreliable delivery. What is the meaning of reliable and unreliable? Now see, if PC1 is going to send any data to any receiver machine server, transport layer will decide that the communication which is going to happen between PC and server will be reliable or unreliable. But what is reliable and unreliable? What is the meaning of reliable? Reliable means
Reliable means that you make sure that the other party receive the the data that you sent by replying.
right.
You send, he make sure he replies,
Acknowledgement, right? Like if
acknowledgement.
PC1 is going to send any information to server, server will give acknowledgement that I have received it. And unreliable means there will be no any acknowledgement. So if my communication is reliable, then that means there is acknowledgement. If my communication is not reliable, that means there will be no any acknowledgement. So which process is going to be fast?
Unreliable.
UDP.
Unreliable, right? Because there is no acknowledgement. So PC will be sending data directly to the server.
Yes.
Doesn't matter server has received or not. Right? So transport layer is going to decide communication is going to be reliable or unreliable. As we have two protocol, TCP and UDP. TCP is reliable and UDP is
Unreliable.
unreliable. Right? First difference between TCP and UDP is reliability and unreliability. TCP stands for transmission
Control protocol.
control
Control protocol.
protocol. And UDP
User
datagram
datagram
User datagram
protocol.
protocol.
protocol. UDP. And first difference is TCP is reliable.
Yeah,
Connectionless.
connection. TCP is
Connection
connection oriented
First one is reliable
and
and
connection
this one is,
oriented.
yes, I'm coming on that point as well. Unreliable. Correct?
Right.
Second
Right.
difference is, see,
Co-
second
connection.
function. First of all, first function. Second function, it perform error correction before transmission. Right? I will talk about this as well. Two protocols are there, TCP and UDP are transport layer. TCP stands for transmission control protocol, UDP stands for user datagram protocol. TCP is connection oriented and UDP is connection less. Now understand the meaning of connection oriented and connection less. So who will explain the meaning of connection oriented?
That's a three-way handshake.
Connection oriented protocol and connection less protocol. Yes, connection for connection oriented protocols, to build the connection between source and destination, it is going to perform three-way
Three-way handshake.
handshake. Three-way handshake. You must have seen this diagram in your book or maybe on the internet many times. PC and server. PC is going to send which message?
Sync.
SYN message. Now tell me, what is SYN message?
Synchronization. The meaning.
Which protocol is going to generate SYN message? What is SYN message? What will be the information inside the SYN message? Only TCP protocol will perform three-way handshake.
Three-way handshake.
In three-way handshake, your sender machine, MAC address is A, MAC address is B, IP address is 10.1, and here IP address is 10.2. Right? So PC is going to send SYN message. What is SYN message? SYN message is nothing but TCP header with SYN bit on. In the TCP header, you will see a flag field, and inside the flag field you will see some flags are there. Out of that, one is SYN flag. SYN means synchronization. Synchronization means initialization kind of thing, right? So SYN message is nothing but TCP header, right? Means TCP protocol is going to generate at which layer? Definitely at layer.
People, sorry to disturb. Means first it will generate the connection.
Yes, it will generate the SYN message first before sending the actual data. I am coming on that as well. First understand what is three-way handshake. This is three-way handshake. In three-way handshake, your sender machine is going to send SYN message. And what is SYN message? SYN message is nothing but TCP header with SYN bit on. With SYN bit on. In the GNS3, if you want to check the TCP header, let's suppose I have one router here, router 2 here, R1 and R2. I'm just going to connect and going to configure IP address here. Let's suppose here my IP address is 10.1.1.1. Here my IP address is 10.1.1.2. So let's take example of any application layer protocol which uses TCP. For an example, telnet. I am going to access router number 2 from router number 1. If you don't know the configuration, no problem, you will understand the configuration here. Just I want to show you the SYN message, right? SYN message means I want to show you the TCP header. Before that, I am configuring IP addresses here. Go to R1, config T. You can also check TCP header in packet tracer with the help of simulation mode. F0/0. no shutdown, and IP
Got
address 10.1.255.255.255.0 R2 config T interface F0/0 no shutdown, and IP address 10.1.1.2.255.255.255.0. Now if I am going to send telnet traffic from router 1 to router 2, telnet 10.1.1.2. Telnet is an application layer protocol which uses TCP protocol at transport layer. So before sending actual data, it is going to perform three-way handshake to establish a control connection, right? And I want to see the traffic on this link, so I can capture this link with the help of Wireshark, right? If you want to see the traffic on this link, you can capture it through Wireshark. If I will hit enter, it will generate the telnet request message, but it will not send telnet request message directly to router number 2. Telnet message will be on hold, and PC is going to generate SYN message first to establish the connection. So let me capture this link to show you the TCP header. Start capture. Okay. Wireshark is already installed in my laptop, and now I am going to hit enter. See some traffic, which is the default protocols running on the router interfaces. Telnet. So before telnet, you can see ARP request message, right? I will talk about ARP as well today. Here you can see the SYN message. If I will open it, you can see in the traffic layer 1 information is there, layer 2 information, layer 3 information, and layer 4 information. Means my actual traffic is at which layer? At layer 4. And the main fields inside the TCP header is source port, destination port, sequence number, and let me open it in detail. You can see all the fields. All the fields in TCP header: source port, destination port. Then here you can see some important sequence number, acknowledgement number, and flags. If I will open the flags, you can see how many flags are there. 1 2 3 4 5 6 7 8 9 10. 10 flags are there in TCP header, and SYN is one of them. So if this bit is on in the TCP header, we call that message SYN message. What we call SYN message. If I am saying ACK message, acknowledgement message, it means acknowledgement bit is on in TCP header. If I am saying SYN plus ACK message, that means SYN and ACK both bits are on. So your PC here is going to send a SYN message that is nothing but SYN bit on TCP header. When your server will receive it, it will check what is the destination port. Destination port is going to be 80 or 443. Server will check that this port number is enabled or not. If this port is open on this server, then it is going to generate SYN plus ACK. Means it is going to generate their on SYN message. The meaning of SYN is nothing but I want to establish a connection with you. On which port number? On port number 80. So now server is saying, yes, okay, first of all, take me the acknowledgement that I got your SYN message. So this is the acknowledgement, and then it will send their on SYN message. Means, okay, I also want to establish the connection, right? And after that, finally PC is going to send acknowledgement, and after this, after exchange of these three messages, both the machine is going to maintain one new table called TCB table. It will have TCP connection, or you can say TCP connection between server and PC. Now all the traffic of telnet or HTTP will go through this TCP connection only. This TCP connection, right? TCP connection is only for reliability, that both machine, server and PC, knows each other, right? Server knows that PC is going to use which port number, and PC knows that server is waiting for data. Means connection is already established. Whatever data I am going to send to server, server will send me the acknowledgement, right? So this control connection is only for one reason, to control the traffic flow between PC and server. Through this control connection, you will see how we can control the flow. For an example, the rate of transferring data on the PC is 100 Mbps, but on the server 10 Mbps. So here both need to negotiate the speed. They will negotiate through this control connection. Server is going to, hey bro, just wait. Please send data slowly. So whatever thing is going to happen behind the, guys, put yourself on mute if there is noise. Like, so TCP protocol perform three-way handshake. This process is called three-way handshake.
Handshake.
Only TCP protocol perform three-way handshake. UDP protocol, if I will talk about the UDP data, let's say DNS data. This is PC, this is DNS server. So PC is directly going to send the. Here
Praful,
anyone tell me
sorry
the.
to interrupt you. Can I ask one question?
Go ahead. Yes, you can ask.
Yeah, so you tell that there is a sync message. So acknowledge, we are aware. So there is a acknowledgement of the message what transmitted by the transmitter, right? So what is the sync? Sync is basically to check the connection or what? So can
To
you tell
establish
something
the
about
connection.
to establish the connection?
Yes.
So
PC is
not
telling to
not to
server.
check the connectivity, not to check the connectivity, only to establish the connection, right?
Yes. To check the
Okay,
connectivity, we have ping ICMP protocol.
right,
TCP
right.
protocol is not used to check the connectivity. TCP protocol decides reliable and unreliable, like communication is going to be reliable. TCP protocol ensures that communication will be reliable.
Sir, like as you said that there is a like source port number 80 and that like in the server section, the port number should be like enable. So like how we can check that like which port number is enabled for server, or is it possible to check?
Yes, yes, definitely you can check. I will show you even.
Okay.
Here by default, can anyone tell me which port number is enabled on the router? By default, which port number is enabled on the router?
Telnet.
L0, L0,
0.
23
L0,
port
loopback
number
interface.
Only
telnet.
telnet protocol is running by default. So command is show control plane host open port number. This command will give you the open port number. You can see router is listening on port number 23. If you will enable HTTP protocol here, IP HTTP server, and now check port number. Now you can see port number 80 is also enabled and 23 is also enabled. Similarly, if I will enable HTTPS protocol, it will enable 443. If I will enable SSH, it will enable port number 22.
So command is show control plane host open ports.
Open port. Yes.
It will not work in the packet tracer, right?
Yes, it will not work in packet tracer.
Okay.
Even it will not work on all the routers. On other routers, command can be different as well. Done. So see, in case of UDP, UDP is directly going to send data, but in case of TCP, after three-way handshake, when both the machine will have control connection, then only it is going to send data. Now your actual data will. Now PC will send the actual data. For an example here between router 1 and router 2, I said telnet. Telnet is not working. Why? But port number is open. Here you can see. Right? If I will check port number 443, you can see 443 port number is not enabled. Right? Telnet is a troubleshooting command. See through telnet how I am checking which port number is enabled, which port number is not enabled on router number 2. If I will say 80, again it is saying port number connection refused by remote host, not enabled. Right? And telnet 23, password is not set, and show control TCP brief. it will give you the control connection. So you can see right now we don't have any control connection. For an example, here I am going to enable password. Go to line VTY 0 to 4 and log in. Later you will learn the telnet configuration as well. Enable password Cisco. Okay, and go to router number 1 now, and let's try to access the router through telnet. Now password is required, but password is not set. Line VTY 0 to 4,
Line
no login. See, I got the login, and here if I will run enable command and Cisco, and if I will show you the control connection, so TCP brief, then you can see the control connection here, the established control connection. One control connection is established between 10.1.1.1 and 10.1.1.2. 10.1.1.1 is using random port number, and 10.1.1.2 is using well-known port number of
23.
telnet. Okay, so this is second
So,
difference
sir,
between, yeah,
sir, what is the difference between login synchronized and login local?
login local
When
will
you are
ask you
doing,
for username and password, and login will ask you only for password, not username.
okay.
Yes. So second difference between TCP and UDP is connection oriented and connectionless. Right? Connection oriented and connection less. UDP is connectionless protocol. It will not establish any connection before sending data. Directly it will send the data. But TCP protocol will perform three-way handshake and establish the TCP connection before sending data. Here you can see some more differences: connection oriented, connectionless. We can arrange the receiving data in sequence in case of TCP, but we can't do that in case of UDP. Right? Let's suppose on the network, because of congestion between source and destination, PC and server, PC has sent some segments. Segments means what? S1, S2 and S3. PC1 has sent 3 segment. In segment number 1, data is, for an example, how is the data. In segment number 2, data is R, and in segment number 3, data is U. So see, data has meaning when the segment is in sequence, correct? When
Yes.
segment has the sequence, then only data has any meaning. But let's suppose because of congestion or any XYZ reason, your receiver machine have first received segment 2, and then it has received segment 1, segment 2, then segment 1, and then segment 3. So if user will get this data, how is there any meaning? R, how, and U. There is no meaning, right? So in case of UDP, now your receiver machine can't rearrange it, right? It is going to give this data only to upper layer, to application layer. But in case of TCP, it will arrange the data in sequence first, right? For that, TCP protocol perform sequencing. TCP protocol perform sequencing. Sequencing is nothing but process of adding sequence number with each and every segments. Process of adding sequence number with data segment. Okay, in case of TCP, data can be retransmit as well, because there is acknowledgement definitely. So if server is not going to receive, let's suppose segment number 1, it will not send acknowledgement for that. So PC will retransmit it, and retransmission is not possible in case of UDP. Definitely it is not possible, because in case of UDP there is no acknowledgement. PC will never get to know that what data is received on the server and what data is not received by server, correct? So data can be retransmitted in TCP. It can't be retransmitted in case of UDP. TCP is a reliable protocol. UDP is an unreliable protocol. TCP has flow control. Flow control can be achieved in case of TCP, but flow control can't be achieved in case of UDP. As I told you, PC has different rate of forwarding data and server has different rate of receiving data. So here flow control is required, right, to avoid the data losses. So UDP can't perform any kind of control, flow control, but your TCP can perform flow control. We'll see with the help of negotiation how it can control the flow. Then windowing services is there in case of TCP. TCP uses a technique called windowing and UDP is not using windowing. Can anyone tell me what is windowing?
Windowing is the amount of data that is transmitted within a certain period of window.
Okay, anything else?
Means suppose PCA is sending any data to PCB, so it previously sets that after receiving, I mean, suppose 3 MB data, you will send the acknowledgement, and not no, every time.
Okay. CPC and again server. PC and server. PC1 is going to send, let's suppose 1000 segment. You are downloading a movie from internet. You are downloading a movie from internet. How many segments are there? 1000 segments. And you know, TCP is a reliable protocol, means after sending data, server is going to send acknowledgement. Let's suppose PC has sent segment number 1 first. Segment 1 S1, server is going to send acknowledgement. Again PC will send segment 2, and server will send acknowledgement. Again PC will send segment 3 and server will send acknowledgement. This way, if receiver machine is going to send acknowledgement for each and every segment, then communication will be very slow. Then communication is going to be very slow. So to reduce the number of acknowledgement, we come up with a technique called windowing. Windowing is a TCP technique used to reduce the number of acknowledgement in TCP data forwarding. How? So while three-way handshake, both the machine, sender machine and receiver machine, are going to negotiate their buffer memory. At the time of three-way handshake, both the machine are going to negotiate buffer memory. And based on that, it will decide a window size. Let's suppose server has buffer size of 100 MB. Example, right? Means server can store how many data in their buffer memory? 100 MB, right? So window size can be 100 MB. Means after sending 100 MB data, PC will expect acknowledgement. PC will expect acknowledgement, right? One server will send acknowledgement now after receiving 100 MB data or 100 byte of data. I can say, let's suppose 2000 bytes. 2000 bytes. So after receiving 2000 bytes of data, server is going to send acknowledgement. Let's suppose again PC has 1000 segments. And the size of each segment is 100 bytes. Size of each segment is 100 bytes. So after how many segments server is going to send acknowledgement? Segment 1, PC will not expect acknowledgement. It will send segment number 2 without acknowledgement. Segment number 3, segment number 4, segment number 5. How many segments it will send?
10.
2. MTU size, if the buffer memory size is 200 byte, then window size will be also 200 byte. Means after sending 200 bytes of data, PC will expect acknowledgement. After sending equivalent amount of data to the window size, PC will expect acknowledgement. It will stop sending data. Let's suppose PC1 have sent segment 1, which is 100 bytes, segment 2 again 100 bytes. Now 200 bytes of data is transferred. Now PC need acknowledgement. It will wait. When server will send acknowledgement, then it is going to send segment number 3. See, one more thing, application layer don't has any limitation. Application layer can generate any size of data. Any size of data. For an example, here I have a PC. This PC is connected with one router, their gateway. This router is connected with another router, right, on the internet. And then we have somewhere server. How many of you know the MTU, guys? MTU?
Maximum transmission unit.
MTU stands for maximum transfer unit. The amount of
Transmission.
Maximum transmission units.
yes, the amount of data that can be transferred from the interface. So all networking devices, your routers, will have MTU of their interface. Let's suppose R3. R3 has MTU size here 100 bytes, here 200 bytes, here again 200 bytes, here 300 bytes, here 150 bytes or 70 bytes, and here again let's say 100 bytes. These are MTU, maximum transfer unit. By default, MTU size of Cisco router is
it transmission or transfer unit, Praful?
maximum transfer unit, maximum transmission unit.
It's transmission
Okay.
unit here.
Transmission and transfer both are same. So here you can see, so interface
1500 bytes.
0/0 include MTU. So what is the MTU size? 1500 bytes by
Wow.
default. By default MTU size is 1500 bytes. So if a router, let's say router number 1 is receiving a data whose length is 300 bytes, can router 1 receive 300 bytes of data?
Yes.
It can receive, right? But can it transfer? No, it can't transfer because their MTU maximum transfer unit is
200.
200,
Okay.
right? So router will drop it. Either router will divide it into multiple parts, that is going to be fragmentation, or if fragmentation is not allowed, it will drop it. For an example, let's suppose here in my topology, if I am going to send ping traffic, ping 10.1.1.2, ping is working. If I will increase the size 2000 bytes, ping is working. And if I am going to say ping 2000 bytes but don't fragment, DF bit, now you can see ping is not working. Why? Because the length of data is greater than the MTU size of router. That's why ping is not working.
Okay.
Okay, so router in this
So
case,
can you explain? Can you explain the size 2000? Is it mean that you're transmitting 2000 bytes?
yes, I am sending 2000 bytes of data.
And the interface is 1,500.
Yes, exactly. That's why router
Yeah,
1
it
is
will not
dropping the
work.
traffic.
But
Yeah.
normally it should normally only with the 2000, but it shouldn't work, right?
Yes, because router is capable to perform fragmentation, is capable to divide the data.
Mm. Is it done? Is it done by default?
Yes, by default router can divide the data. We'll talk about the division of data on router as well as at the transport layer. Just wait. So is MTU clear?
I am having one query regarding you told that if 300 byte will be received but not able to transmit, R1 will not be able to transmit 300 bytes, right?
Correct.
But there is a parameter like MTU, there is a MRU also, maximum receive unit.
Okay.
So that also need to configure. Then in that case, what I guess it will be able to receive 300 bytes. If MRU will be 300, in that case R1 will be received. R1 can receive, right?
Okay. Yes.
Correct me if I'm wrong.
Yes, absolutely. Right now I am only talking about MTU. Right? So forget about the receiving. Just imagine that router can receive any size of data, but it cannot forward, transfer the data whose length is more than 200 bytes. So how PC1 will understand that what should be the size of my data before sending? PC need to negotiate the minimum MTU between source and destination, right? PC will negotiate the minimum MTU between source and destination. See, if PC is going to send a data with length 100 bytes, can it reach to server? Can 100 bytes of data reach to server? No. Which device will drop it? It can reach,
The
guys.
router 3.
It
R
can
three.
reach. It can reach to the server, but reply will not come. Router 3 will drop the traffic. Router cannot transfer the reply from this interface.
70 interface.
Yes. If I am sending 150 bytes of data, which router will drop?
Router 3.
R1.
After
R1 can
3,
forward it. The MTU size of R1
no,
is 200. So it can transfer. R2.
it's router 3.
R3
R2 can also transfer, their
R3.
MTU size is 300. Right?
R3
I am not talking about receiving interface. Forget about that for now.
Transmitting.
Yes. Now R3 can't forward it, right? Because their MTU size is 100 and the data size is 150 bytes. So before sending any data, TCP protocol perform three-way handshake, and during three-way handshake, both the machines are also going to negotiate the minimum MTU size. So what will be the minimum MTU size between source and destination?
100.
It is 100, not
Sir,
100, 70 bytes. Now based on this minimum MTU size, your PC will decide the size of segment. That one segment should have what length, right? But what it will be, application layer don't have any limitation. Application layer can generate any size of data. So for an example, here my application layer, my HTTP protocol has generated a HTTP request message whose length is 1000 bytes. Application layer has generated a data whose length is 1000 bytes. Application layer will send it to transport layer, right? Now another function, or you can say even this is the first function of transport layer. What transport layer will do? Transport layer will divide big size of data into a smaller part of data. That is called segmentation. That is called
Fragment.
not fragmentation,
Fragmentation.
segmentation.
Segmentation.
Fragmentation is dividing large size of data into a smaller part at layer 3. The meaning of segmentation and fragmentation is same, but both are different. One, segmentation means dividing data at transport layer. Fragmentation means dividing data at
Layer 3.
Layer three.
Okay, right.
So fragmentation will
Like that.
happen.
This is packets.
Yes, fragmentation happens for UDP traffic because in UDP there is no three-way handshake, right? So UDP protocol cannot negotiate the minimum MTU. So UDP can send any size of data to router. In that case, router have to divide. Or fragmentation will happen for layer 3 data, right? Like your ICMP. ICMP works at layer 3. ICMP protocol will generate messages, their data at network layer. Again, three-way handshake will not happen for network layer traffic. So router should be capable to perform fragmentation, right? So now you need to find here on the PC what should be the size of segment, maximum segment size, MSS. And formula to find maximum segment size is minimum MTU minus transport layer header size and network layer header size. Because yesterday what we had learned, that transport layer is going to add either TCP or UDP header, network layer is going to add either IPv4 or IPv6 header. So whatever size is there, let's suppose TCP header has size of 20 bytes. 20 bytes. And network layer header size length is also 20 bytes. Then what should be the size of MSS, maximum segment size? What should be the size of segment?
70.
Minimum MTU is 70. 70 minus 40, 30, right? 30 bytes. If default MTU is 1500 byte, then what should be the size of my segments?
1470.
60. 460 bytes, right? This is the size of one segment.
Is it 1470?
1460.
60.
Because it's 20 byte and 20 byte, which is 40 bytes.
Oh,
So
yeah. Sorry. Lost it.
Okay. So now windowing is clear, used to reduce the number of acknowledgement. First, both the machine, sender machine, receiver machine, are going to negotiate minimum MTU. Based on that, it will decide the segment size, that what should be the size of segment, and then based on buffer memory size of receiver device, it will calculate the windows size. And after sending data equivalent to windows size, your sender machine will expect acknowledgement. If it will not receive acknowledgement, it will retransmit the data. It will perform retransmission. Then four-way handshake is used to terminate the connection. Let's suppose when PC1 is done with data transfer, the PC1 has sent all the data to server, but TCP connection is still there. Now PC1 will send fin bit, right? In the caption you can see some important flags. One is SYN flag. SYN flag is used to establish the connection. Fin flag is used to terminate the connection.
whose background is that?
SYN is used to establish the connection. Fin is used to terminate the connection, right? Then acknowledgement. Can anyone tell me the name of the person?
Man, Gideon, can you not unmute yourself? There's lots of noise.
The person is seen is routine. Fasal.
Okay,
Amid.
leave. Wait. SYN, then fin, then acknowledgement, and some more flags are there, like you can see reset. Let's suppose your PC is sending SYN message on port number 80. Destination port is 80 and port number 80 is not enabled on the server. It will send what? Reset message. For an example, see here. From PC1, I am going to send traffic on port number, let's suppose 600, right? So port number 600 is not enabled on router number 2. Port number 600 is not enabled on router number 2. What will happen? See, PC has sent it, means router 1 has sent it SYN message, and router 2 has reply with reset message. Reset message is used to tell your sender device that this port number is not enabled. That reset the connection. Reset the connection. Right? Some more flags are there. Some more flags are there, like you can see push flag, urgent flag. These flags are used to send data urgently, right? ECN flag is there, then congestion flag, right? So I will talk about these flags as well later. For now, remember SYN, FIN, reset and acknowledgement. Reset and acknowledgement, these flags. So these are the flags through which TCP can control the flow. Through these flags, TCP can control the flow. After that,
Can I ask a question, Professor?
yes, you can.
About a reset flag, in what all scenarios you could see the reset? Could that be generated due to an application level error, but you would still see it at a transport layer?
If port number is not enabled, then it is going to see a reset flag.
Okay.
And every time we see a reset flag, that means that the port is not working, right?
Correct.
Yeah, because I was literally troubleshooting the same issue today, where we have a rel-based server in a network. I saw TCP flow with the reset flag, but on this Linux server, we had IP tables, we had whitelisting available, we had the source subnet whitelisted and port open for it. Even then, the end user had that TCP reset. So then I'm thinking from a network perspective, layer 1 to 4, the setup is all okay from end to end. All whitelisting routes there at a server level, IP tables, ports open. So that's all there. Because on that server, obviously, there's an application which is used by the end users, which are connected through a cross connect. I'm thinking like the reason I couldn't find an issue from a layer 1 to 4 perspective. So I'm thinking that would a application generated error still cause a reset flag?
Only application creates this flag error issue. This issue, right? If there is issue till transport layer, then we will not get the reset flag. We'll even not get the traffic at layer 3, at layer 4. That means till layer 4, everything is working fine.
Yeah, fair enough. Okay. All good. Thank you. You may continue.
So remember this function of transport layer, right? At transport layer, if my protocol is TCP, it will perform segmentation, means it will divide large size of data into a smaller part based on minimum MTU between source and destination, and it will expect acknowledgement after sending equivalent data to MTU size. You can see the default header length size of TCP is 20 bytes and the default header length size of UDP is 8 bytes. These are the application layer protocols which uses TCP. These are some application layer protocols which uses UDP. Segmentation is done in TCP, segmentation is not done in UDP, right? So as UDP will not perform segmentation, it will not divide large size of data into a smaller part, and if router MTU is lower than the data size, then router can perform fragmentation. Then router should be able to perform fragmentation, otherwise it have to drop the traffic. Then again same thing, connection oriented, three-way handshake, sequencing, as I told you, the process of adding sequence number with data so that receiver machine can arrange it in proper sequence. MTU, retransmission, reliable flow control, and windowing. Four-way handshake to terminate the connection. See FIN, sender machine will send FIN message after sending all the data. Receiver machine will send acknowledgement and they are on FIN base, and after that finally sender machine will send acknowledgement. So 4 messages are there. That's why we are saying four-way handshake. And if I will show you the TCP header, then here also you can see what informations will be there. See, this is what TCP header. Source port number, the most important field. Destination port number, second most important field. Sequence number, acknowledgement number. The length of sequence number is 32 bits. It is 32 bits decimal value. Range can be 0 to 2 power 32. Acknowledgement is also same. Then header length will be there. Reserve, flag, window size, checksum, and urgent point. These are the fields of TCP header. Means one TCP header will carry these all. Information. What is checksum?
Error checking.
Right? I told you TCP perform error detection, right, with the help of checksum. Guys, checksum is one algorithm. You know, like juicer. What happened? Let's suppose here I have juicer in my home. If I will put apple in the juicer, it will give me apple juice. Here is the output. Here I will give input and here it will give me the juice output. So it is one kind of algorithm. Here in the checksum, similarly in the algorithm, you will put your all data. Your all data. For an example, my data is how are you? How are you? Right? So I have put my data in this algorithm and it is going to generate some hash value for me. Let's suppose hash value is at the rate ABC123. This is hash value with this data. Now what transport layer or TCP protocol or transport layer will do, it will add this checksum hash value in the checksum field with your data. What is the benefit? When receiver machine is going to receive it, receiver machine will do also same thing. Receiver machine also has the same algorithm, same juicer. Receiver machine is also going to put data in the algorithm. It will also find the checksum value. If checksum value will match, that means data is not modified over the network. If the checksum value will not match, that means data is modified. Algorithm like MD5 on the Google, if you will check MD5 calculator, let me show you. MD5 has generator. So here if I am going to give any data, let's say how are you, and generate the hash value. Now see, it has generated the hash value for me, 2 hash value, MD5 hash value and SHA-1 hash value. I'm going to copy it and let me put it in my notepad for now and see. This is my hash value. So receiver machine will verify that hash value is matching or not. If data is how are you only, then hash value will be same. And if anyone is going to modify, let's suppose even if you will add one dot here, then your hash value is going to be changed. Now you can see your hash value is different, right? So if someone will modify the data on the network, receiver machine can understand it, the data is modified, it will drop it, right? So checksum is used for data modification, like data is modified or not on the trunk link. Urgent point, it is definitely used to send data urgently. Like later you will learn one more thing in QS, how router process the data. First it will store the data in buffer memory, then scheduler will pick it and out from the outgoing interface. So let's suppose 100 segments are there in the buffer memory, and you want always all the devices between source and destination should process this segment, right? This is urgent, like the ambulance on the road. Ambulance has one signal, right, that here you should give the space. That is priority. So it is priority kind of thing to send the data urgently. It will turn on urgent field on the segment, and all the router will process, pick that segment first. Here you can read about all the fields like source. This is 16 bits value that specify the source port number of sender device. Destination port 16 bits value that specify the port number of receiver. Sequence number 32 bits. Address decimal value used by TCP that put the data back into the correct order or retransmit missing data during the process called sequencing. Acknowledgement, again same thing. Header length, it is going to tell you the length of header so that at transport layer my receiver device can calculate the actual size of data, right? If let's suppose at transport layer total length is 100 bytes and header length is 20 bytes, that means first 80 bytes of data is the actual data. Reserve, it is always set to 0, it will be always reserved. Flags, I have shown you some flags. Total here we need to learn total 8 flags, okay, and I will talk about rest flag later. In NANP we need to learn the most important 8 flags in TCP header to understand the flow control. Window size, this will negotiate the buffer memory of interface and then decide one window size, and with the help of windowing we can reduce the number of acknowledgement. Checksum used to find the error in the TCP header. Urgent point used to send traffic urgently, and option, it is optional field, like if you want to increase the size of TCP header you can use it. Now PC.
Praful, I have question regarding the urgent point. The urgent point is similar kind of QS, right?
Right.
Or the same thing. QS we have to apply on that traffic.
Correct.
Sir, I have a doubt in this option field.
Go ahead.
So until how much bytes we can add in that? Is there any limit for that?
No limit. Here like you can see how I can increase any size. It is like that. Size
Okay.
depends on your operating system.
Okay, sir.
So does that affect the jumbo frame?
Sorry?
Does that affect the jumbo frame?
Option field.
Is
Hello.
Can you hear me?
Yes, I can.
Does that affect the jumbo frame?
What can affect
How are you
the
going to
jumbo?
calculate?
What?
Like the size of packet, if that's like the 1460 is the maximum one, right? And how you connect that to jumbo frame then?
Okay, wait.
To 9000.
Got your question. Just wait for some time. You will understand.
Okay.
See,
Okay.
here is a PC. Now my application layer has generated some data. It is going to send it to transport layer. What transport layer will do? Transport layer will check that this data is going to be transmitted either by using TCP or UDP first.
UDP.
If it is TCP based traffic, then it will send SYN message. Receiver machine will send SYN plus ACK. Again, PC will send ACK. And during three-way handshake, how many things it will negotiate?
Windowing, MTU windowing.
Minimum MTU and buffer size. After that, it will decide the windows size. And both the machine, sender machine and receiver machine, will establish TCP connection, right? So in the TCP connection, you have seen the source port number for 10.1.1.1 and port number for destination device, let's say 8.8.8 is fixed. Now whatever data PC1 is going to send to the Google server, source will be always that port number only. If you will reset the TCP connection, then your source port is going to be changed, because now server machine know that okay, I am going to receive data from this port number from this PC, right? It is waiting for the data. Here I will keep my buffer memory empty to receive the data from PC number 1 on this port number. If server is going to receive data from the another port number, let's say buffer is not available, both PC1 is also sending the data and PC1 already have the TCP connection. At the same time, another PC is also trying to send TCP based data to server, but server cannot process that because buffer memory is full, right? So server will always process the traffic coming from the PC, because the port number, source port number on through which it is receiving the traffic is already reserved, has already TCP connection, and TCP connection which is established between source and destination, between PC and server, can control the communication, right? What should be the flow of data, at which rate PC should send the data, right? At which rate server is receiving the data. Based on that, it can inform to PC that send me data at this rate, and after that your transport layer is going to send data to lower layer. Yesterday I had also told you one more thing, that segment means
The portion of data.
segment is data, or you can say a small part of
A
data
portion of data.
plus TCP header, right? So I am assuming minimum MTU is 1500 bytes. Minimum MTU is 1500 bytes, and application layer has generated one data whose length is 5000 bytes. 5000 bytes. So tell me, your TCP protocol at transport layer is going to divide this data into how many small parts?
Three parts. Three parts. Three parts.
1500 or 1460? 1460. Again 1460. Segment 2. Then segment 3. And segment 4. What will be the length of this fourth segment? The data length of fourth segment?
$640.
620.
620, sir.
620
Yeah,
bytes.
sorry, 620.
Now these are small parts. Now transport layer is going to add TCP header with all the segments. What it will add? TCP header. In TCP header, source port number 1024, destination port number 80, sequence number acknowledgement number, right? Maybe acknowledgement number will be 0, sequence number 1. In all the TCP header, it is going to add source port, destination port, sequence number, whatever information we have seen in the TCP header. And this particular field is called, this particular data is called segment. And then segment 1, or you can say S1, segment 1, segment 2, segment 3, segment segment 3, segment 4. It will send, transport layer will send these all 4 segment to network layer, to lower layer, to network layer. And now what network layer will do? Network layer, now network
It
layer
will
is going to add
source and destination IP.
Yes, network layer is not going to perform division. It will not divide the data. Network layer provide the logical addresses to your data. The main function of routers protocol at this layer, these are the protocols, right? I will talk about this later. Here I want to show you the header. Here you can see the UDP header. If your protocol is UDP, then UDP is only going to add source port, destination port, header length, checksum. That's it. These 4 fields in the UDP header. Like if I will say here, if I will show you the UDP header as well, how I can check the UDP header? I can do one thing, go to interface, F0/0 and IP address, DHCP. Here you can see DHCP message. Which protocol is working at transport layer? You can see UDP message at application layer, then sorry, DHCP protocol at application layer, then UDP protocol at transport layer. And in UDP protocol you can see the header, source port, destination port, UDP payload, checksum and length. That's it. Now IP protocol, IPv4 protocol is going to add this header. This header. In this header you can see version. First of all, IPv4 version or IPv6 version. Then header length. TOS field is there. 8 bits is there for quality of service, right? This is to prioritize the data at network layer based on IP, how we can prioritize the traffic. Total length of data, not so important these fields until unless you are not using QS. Then identification field is there. This field will be in use only when router will perform fragmentation, right? Flags is there, 3 flags are there. Fragmented offset is there. Time to live, again this is very important field. Protocol, very important field. Checksum is exactly similar like the TCP header. Source IP, destination IP, and then optional again to increase or decrease the size of header. See, so time to live, protocol and source IP and destination IP, these 4 fields are so important for now to understand our packet flow. Tell me one thing, at transport layer how you will identify the data, that data belongs to which protocol? At transport layer how you will identify the data?
Port number.
Port number, right? Let's suppose this is my server, and on the server multiple protocol is configured, 80, 443, right? Then 23, 22. Let these all port numbers are enabled, and IP address is 10.1.1.10. and here is a PC. PC1, with IP 10.1.1.1. Okay, so in the browser, in PC1, in the browser, I said 10.1.1.10 means I have browsed this IP address. What will happen? My HTTP protocol or HTTPS protocol is going to generate request message. It will send this request message to transport layer. Transport layer is going to add source port number and destination port number. Let's suppose 80. Then it will hand over it to lower layer. Network layer is going to add IP address, source IP 10.1.1.1, destination IP 10.1.1.2. See, when you are sending HTTP data, then also destination IP address will be 10.2. When you are sending telnet, then also destination IP will be same. While sending any data to this server, destination IP address will be 10.2 only, the IP address of server. But port number is going to be different. On the server, when server will receive this data, at network layer it will check that okay, this traffic belongs to me. Someone has sent the traffic for me. But how network layer will understand that at layer 4 TCP protocol is working, right? Because this layer 4 information will be handled by IPv4 protocol. IPv4 protocol is going to check destination IP address. Destination IP address is 10.2. Yes, it's my IP address. IPv4 protocol will remove this header, IPv4 header, and it need to send data to upper layer to either TCP protocol or UDP protocol. How it will understand that upper layer protocol is TCP or UDP?
I guess with the help of port number.
Port number is at layer 4. IPv4 protocol cannot check port number. IPv4 protocol can only understand layer 3 information, right?
Yes.
It cannot check port number.
Okay.
Based on fields?
Which field? Based on protocol field. See, in all the header, whether it is layer 2 header, data link layer header, network layer header, or transport layer header, you will see some information through which you can identify the upper layer information. Like here, you can see transport layer. At transport layer, TCP protocol is going to check this header, and TCP protocol will check destination port. If destination port is 80, then I need to send actual data to HTTP protocol.
Deepa, can you mute? Deepa, please mute.
Based on port number, it can check actual traffic belongs to which protocol. At application layer, 4 protocols is running. 4 protocols are running: HTTP, HTTPS, Telnet, SSH. So TCP protocol need to send actual data to which protocol? Based on destination port number, it can identify. Similarly, IPv4 protocol will check protocol field. Which field? Protocol field. In the protocol field, there will be protocol number. Now question is, what is protocol number? We have learned the port number. Now new thing is there, protocol.
Before that, Praful, I'm having one question.
Go ahead.
So this port number is 1024 and 80. Means source port is 1024 and destination port is 80. So what it means? I mean, there is a different port now.
Source port is the random port number. Destination port is the well-known port number. What is the difference between what? Like PC has generated the traffic. On PC1, it has added TCP protocol has added the source port. So source port will be any random port number, and destination port will depends on the actual data. If it is HTTP request, then destination port will be 80. If it is HTTPS request, then it is going to be 443. If it is telnet request, then destination port 23. SSH request port number 22. What is protocol
Okay,
number?
you mean to say कि the traffic generation port can be anything, right?
Yes. Source port number can be any port number.
Okay, it is a random.
Yes. What is protocol?
And okay, one more question I'm having, this application layer protocol you told, but there is no protocol on presentation and session layer.
You don't need to learn. You don't need to learn any protocol at presentation layer and session layer. There are so many things at application layer, like creating application as well, right? Developing application. But will we learn that? How to design the application?
No, no.
It is like that. Whatever for us, we are covering that only.
Okay, just ask for knowledge only. So there are protocols exist in presentation and session layer also, right?
Correct. Correct. I have told you presentation layer perform encryption. So definitely there will be some protocol na, for encryption. How it can perform encryption without having
Right.
protocol? AES, DES, these are encryption protocol algorithms. What is protocol? Port number is the identity of application layer protocol. But what about the protocol which is running below application layer? For an example, at transport layer like TCP, UDP, or at network layer OSPF, EIGRP, IPv4, IPv6. How to identify these protocols? So these protocols are identified by protocol number. TCP protocol uses protocol number 6. UDP protocol uses protocol number 17, right? So here in the IP header, your PC will add port number of TCP protocol, which is 6. Means which protocol has handover data to me. Now understand again. HTTP protocol will generate HTTP request message on the PC1. Your application layer protocol will just generate the data and it will send to transport layer. Transport layer is going to add source port and destination port. Source port random port number and destination port destination port 80, and then other field like sequence sum, checksum. Okay, now it will hand over to lower layer, to network layer. Network layer is going to add source IP 10.1, my IP address, destination IP address, you will tell that 10.1.1.10, and protocol number 8. Who hand over this data to IPv4 protocol? TCP. So protocol number of TCP 6. And then it will hand over to lower layer, to data link layer. Data link layer will add source MAC, destination MAC, and upper layer information. Source MAC A, destination MAC B. And who hand over data to data link layer? IPv4 protocol. So there will be type code of IPv4 protocol. Can anyone tell me the type code of IPv4 protocol?
0x0800.
This is type code of IPv4 protocol. Now, PC1 will send it to server. Server is going to receive at physical layer. Physical layer will convert it into frame. It will forward to data link layer. Data link layer is going to check destination MAC. If destination MAC will match, it will accept at layer 2. It is going to check type field. Type, with the help of type field, it can understand the rest data except layer 2 header belongs to IPv4. So data link layer will remove it and it will hand over these all data to network layer. Network layer is going to check destination IP address. If this is my IP address, then let me check the protocol field. Protocol value 6 means apart from the network layer header, rest data belongs to TCP protocol. So it will hand over, IP protocol will hand over it to TCP protocol. TCP protocol is going to check destination port number. Destination port number is 80. It will remove this header and it will send this rest information to HTTP protocol, and HTTP protocol will generate HTTP reply message. Here, if I will ping router 2 from router number 1, ping 10.1.1.2, at which layer router 1 is going to generate traffic?
Layer 3.
Right? So when I am saying HTTP works at application layer, it means HTTP protocol is going to generate their all messages like HTTP request, HTTP reply at application layer. If I am saying ICMP works at network layer, layer 3 means it is going to generate their all messages at network layer. There will be no TCP, no UDP, no application layer, right? Your data, there will be the data which is going to be ICMP request message, plus IPv4 header plus Ethernet header, layer 2 header. That's it. So let me show you ping 10.1.1.2. What happened? IP is not configured. Interface F0/0 IP address 10.1.1.1.255 and ping. See, ping is working, and if you will check the data, you can see your data is this one, internet control message protocol. At which layer? At application, sorry, at network layer. Then network layer header, data link layer header, and then physical layer means your data in bits. So if you will open ICMP message, you can see type code is 8 means it is ICMP echo request message, right? For request it is using type code, and for reply 0. For reply 0. Then network layer header means IP header. In IPv4 header you can see source IP 10.1, destination IP 10.2, time to live, and protocol. Protocol field is, protocol value is 1. 1 is the protocol number of ICMP. It mean what? It mean apart from this network layer header, whatever information is there, that is for ICMP protocol. If protocol number will be 6, that means all rest information is for TCP protocol. If it is 17, that means for UDP protocol. If it is 89, 89 is the protocol number of which protocol?
OSPF.
OSPF. EIGRP is using which protocol number?
88.
88. Right? So at network layer we can identify the payload with the help of protocol number. At Ethernet header, at layer 2, in the Ethernet header you can see what field is there, type field. Through type field we can identify the payload. That payload belongs to IPv4 protocol, right? And if I am going to send any layer 4 traffic, let's suppose telnet 10.1.1.2. So let me show you the SYN message, which is the transport layer traffic. So here you can see my traffic is at transport layer. Only header is there, right? There is no any traffic. I told you that SYN message is nothing but the TCP header with SYN bit on. Right? So here we have transport layer information, network layer, Ethernet layer, means layer 2 and physical layer. So at layer 2 you can see type field. Type field is IPv4. Type code of IPv4 means layer 2 is going to hand over it to IP protocol. IP protocol is going to check protocol value. It is going to be 6. So IPv4 protocol is going to hand over it to UDP protocol. UDP protocol is going to check destination port number. Destination port number is 23. That means this is telnet traffic, but SYN bit is on, means someone is trying to establish the connection. It will send SYN plus ACK. Now understand packet flow between two PC. Let's suppose PC1, and one more thing here. See PC1 and server. Again here I have actual HTTP request message at application layer. This is what? My data. We call data to data only at application layer. This is application layer. Application layer will send it to transport layer. Transport layer is going to add HTTP request message will become payload, means your data plus TCP header. TCP header. And what we call it?
Segment.
Now we call it segment. Segment. So two things are there. You can see one is payload, your data, and this is header. This is header, the extra information.
Sir, 80 is the port number and 1024 is?
That is also port number. That is source port number.
Okay. This is the source and this is 80 is the destination.
Correct.
Sir, whatever data is provided by upper layer, that is called payload, right?
Correct. Segment. Now, network layer will receive what? Segment. And this segment is payload at network layer. Segment. This segment is payload, and network layer is going to add
IP header.
Network layer header, right? Either IPv4 or IPv6 header. Soon I will talk about TTL as well. Just wait. 10.1.1.1 destination IP 10.1.1.2 and protocol number 6. Right? Because who have hand over the segment to IP protocol? TCP protocol. Right? So that's why protocol number is 6. Again, what is this? This is payload. Payload, and this is
IP header.
Header, IP header. And what we called it?
Packet.
Packet. Right? Now, network layer is also going to hand over it to lower layer, data link layer. Data link layer is receiving what?
Payload.
Packet. This packet is nothing but payload at data link layer. And data link layer is going to add their own Ethernet header. Source MAC A, destination MAC B, and type
Field
0x0800. Again, this is what? Payload. Payload, and this is header. And what we called it?
Frames.
We called it frame. and then it will hand over to physical layer. At physical layer we are going to call it bits. It will convert everything into bits. So your server is receiving data, which is HTTP request, then there is segment, then there is packet, then there is frame and bits, right? So it will receive bits, it will convert bits into frame, right? If it will when data link layer will open the frame, there will be two things. In the frame there will be two things, payload plus header, right? So data link layer is not going to check payload, it will only check what? Header. And based on header information it can understand the payload belongs to which protocol. Payload belongs to C type code IPv4 protocol. Similarly, IPv4 protocol will open the packet because data link layer is going to send the payload, which is the packet, to network layer. Network layer is going to check packet. Network layer will open the packet. Inside the packet there are two things, like inside the frame there are two things, packet plus header. So it will send this packet to network layer and it will remove the header. Network layer is going to open the packet. Inside the packet there is segment and header. So it is going to check the header, and based on header it can identify the payload. Payload is segment, and then it will send the segment to upper layer, to the TCP protocol at transport layer. TCP protocol will open the segment. Inside the segment again two things are there, payload plus TCP header, and in the TCP header with the help of port number it can send the actual payload to any protocol at application layer. This way decapsulation will happen on the server. PC will perform encapsulation, server will perform decapsulation. Now understand one thing, one problem here. PC1, here I have PC1, and even I am going to send now ICMP packet, right, at layer 3, just to make it easy. Otherwise you can take example of any protocol. If you know the packet flow, this packet flow, the base, you can understand the packet flow for any protocol. Protocol doesn't matter, right? Because protocol is only going to generate the actual data. This is server S1. Here MAC address is A. Here MAC address is B. Now what we have learned in previous class, that whenever I will configure IP address over here 10.1.1.1, my PC is going to start maintaining a table called ARP table. And server is also going to generate ARP table 10.1.1.2. Let's suppose in their ARP table there is one entry, my IP address, my MAC address. Server also has one entry, my IP address, my MAC address. Now if you will ping 10.1.1.2, ping 10.1.1.2, what will happen? PC1 is going to generate ICMP request message, means your ICMP protocol is going to generate ICMP request message at which layer?
Layer 3.
At layer 3. Then
Network layer.
ICMP protocol will hand over to IP protocol at same layer. IP protocol is going to add source IP, destination IP protocol, source IP 10.1.1.1, destination IP 10.1.1.2, and protocol value 1. Who hand over this traffic to network layer? To IPC
ICMP.
protocol? ICMP, so protocol number of ICMP. Now it will hand over to lower layer, data link layer. Data link layer is going to add source MAC and destination MAC. Source MAC. How it will find the source MAC? ARP table. Source MAC will be the MAC address of PC1 only, A. Destination MAC will be what? For
This is
destination
not.
MAC, PC is going to look up ARP table, but you can see in the ARP table, destination MAC address is not available. So your data link layer, a data link layer actually protocol is ARPA. ARPA protocol cannot encapsulate the frame. Here your frame is incomplete. Yes or no?
Yes, sir.
Frame
Sir,
is.
here I have a question actually.
Go ahead.
So whenever we first we introduce the grp, whenever we configure the IP address, it's generate the grp. So that is the question actually. So if whenever we assign the IP address to PC1, it will automatically generate a grp and it will be get some duplication and all the remaining details, right? For
Right.
the ARP entry and other. So in that time, that grp will also get the MAC address for that means this functionality. ARPA will, yeah, definitely going for the get the unknown IAM MAC address. But what is the function in the grp? What is the difference yet? That is my question actually.
grp is used to check duplicate IP address. When you will configure 10.1 on PC1, PC1 is going to ask to everyone that, hey, is there anyone who is using this IP address? No one is going to generate reply. PC will understand that this IP address is not duplicate.
Okay, so that grp is not going to be grab the MAC address of any of the host machine, right?
No?
It's only for the duplicate
Yes.
IP or not is checking.
Yes,
Okay.
exactly. Okay, so it is incomplete. Now what will happen? ARPA protocol cannot encapsulate the frame here. ARPA protocol will put this message on hold and it is going to call ARP protocol. Hey ARP, come here. ARP will say, yes, tell me what happened. ARPA protocol is going to say that, bro, I need MAC address of 10.1.1.2. Just find it. Just find it. Now what ARP protocol will do? ARP protocol will simply generate one ARP request message. ARP protocol will generate one ARP request message. Now this message, actual message is on hold. Timeout, ICMP timeout is 2 seconds. Within 2 seconds, if ARP protocol can resolve the MAC address of destination IP address, then fine. Otherwise PC is going to drop it. ICMP protocol will drop it on the PC only. Okay, so see what will happen for ARP. ARP protocol is going to generate a ARP request message. ARP request. In the ARP request message, there will be some information. Number one, target IP address. Target IP address will be
1.2.
10.1.2. Right? I need MAC address of 10.1.1.2. Okay, and then again ARP protocol will hand over this ARP request message to ARPA protocol to encapsulate it into frame. Otherwise it can't send directly ARP request message. So now ARPA protocol is going to add Ethernet header again. In the Ethernet header, source MAC and destination MAC. Ethernet header.
So PCs like PC1 cannot send the like ARP request directly. So first you have to like send the ARPA, then ARPA will request the ARP.
If there is no address, definitely you can't send, na? Yes.
Okay.
So ARPA protocol is now going to add again source address A and destination address broadcast, all F, and it will send from their interface. Means it is doing the broadcast now. It will ARPA protocol will send it to lower layer, physical layer will convert it into bits, and then it will transmit from the link. All machine in my network will receive this ARP request message. Everyone is going to perform decapsulation at layer 2, and here type field will be the type code of ARP protocol this time, 0x806 0x806 type code of ARP protocol. Now when server will receive this ARP request message, server is going to first check destination MAC address. Okay, destination MAC is broadcast. If it is broadcast, it can be for me as well. Let me check the type field. Type field is ARP. This is type code of ARP. So what ARP server on the server ARP protocol will do? It will remove this Ethernet header and it will hand over the actual payload to ARP protocol. ARP protocol has received one ARP request message. So definitely ARP protocol will generate ARP reply message. It will generate ARP reply message. And in the ARP reply message, target IP address 10.2, target MAC address B, source MAC address B, destination MAC address A. It will send to PC, and PC1 is going to update their ARP table that hey, IP address 10.2 and MAC address B. And now the actual ICMP message which was on hold will be encapsulated into frame destination B, and then it will send to lower layer. If this process R process will happen within 2 seconds, then fine. Otherwise it will drop this ICMP request message and it will generate another request message, and it will store this information for 4 hours if this is Windows operating system. Let me show you once the R process in your packet tracer. Let's suppose here I have one switch and some PCs, PC 2, 3, 4. Okay, if I will open the simulation and I will configure the IP address here 10.1.1.1, and let me check the port of switch is not up now. Let me up it. You can see this is what? This is GRP, not GRP. This is another message. Okay, PC1 has sent the GRP. Wait a minute, sometime it will give you the error. On PC number 2 I am going to configure IP 10.1.1.2, and see it has generated the GRP. In the GRP message, source MAC address is the MAC address of PC2, destination MAC address is broadcast, right? Source IP and destination IP both are same, the IP address which I have configured on PC. So who will generate reply? If anyone is using this IP address 10.1.1.2, but no one is using this IP address in my network, so all the PC is going to drop it. Done. Similarly, PC3 will also generate GRP 10.1.1.3. PC4 will also generate GRP, and all is going to assign IP addresses. Done. Now, if I will send the data, while sending data, it will check ARP table. In the ARP, you can see no entry found. There is no any entry available. So if there is no any entry available and I am going to send any traffic, ping 10.1.1.2, and let me open the simulation mode again, and now hit enter. Now you can see PC1 has generated how many messages? 2 messages. One is ICMP and one is ARP request message. In the ARP request message, you can see source MAC is the MAC address of PC1, destination MAC is broadcast, source IP address 10.1, destination IP address 10.2. If you want to check information in detail, you can check outbound PDU, protocol data unit, and here you can see the Ethernet header. In the Ethernet headers, source MAC, destination MAC, and type. In the ARP request message, you can see the source MAC address, source IP address, target MAC address, and target IP address. Means for this IP address, MAC address is 0.0.0. 0.0.0 means unknown. Means this MAC address is unknown. Okay, PC will send it to switch. Switch will send it to all other PCs. PC3 and PC4 is going to drop it, and PC2 will generate ARP reply message. In the ARP reply message, in the ARP reply message, if you will check outbound PDU, then here you can see in the ARP reply message, source MAC address is the MAC address of 10.2, source IP is 10.2, target is 10.1, target IP and target MAC. And at layer 2, this is unicast message. Now PC2 is also going to learn the MAC address of PC1 because it has already received the ARP request message. Now PC2 know what is the IP address of PC1 10.1, what is the MAC address of PC1 10, whatever MAC address is there, and it will send to PC1. Now PC1 is going to update their ARP table, and after that it can encapsulate the ICMP echo request and it will send the ICMP echo request message. Now you can see in the ICMP echo request message, source IP, destination IP, and source MAC, destination MAC. Destination MAC is unicast. It has encapsulated. It will send to P switch, and switch will forward it to PC2. This is what unicast. How switch forward traffic? You already know this, right? Now all that communication between PC1 and PC2 is going to be unicast. Now next time when I will send any traffic from PC1 to PC2, it is not going to generate ARP because in the ARP table you can see MAC address of 10.2 is already there. But if I will send any traffic to PC3, again it will generate ARP request message. Let me show you. Go to PC1 and again ping. This time you can see it has only generated one packet, one ICMP packet. But if I will ping PC3 means 10.3, then you can see 2 packet, right? So whenever PC will not find MAC address of a IP address in their ARP table, then only it will generate ARP request message. What is ARP? ARP is a layer 2 protocol which is used to resolve MAC address from IP address. I have told you the basic requirement of communication is source IP, destination IP, source MAC, destination MAC, right? So PC1 already have source MAC, already have source IP, and you already told about the destination IP, that ping 10.1.1.2. Only one thing is missing, which is destination MAC address, and that can be resolved, that can be found with the help of ARP request message, and this way it will talk. If I will take example of any protocol, packet flow of any protocol, PC, and let's suppose telnet packet flow between, where is my capturing? I think I have removed the capturing. Let me start the capturing again. Yes. Start where song. Yes, if I am going to say here telnet and 10.1.1.2, what will happen? At application layer, telnet protocol is going to generate telnet request message, then it will hand over to lower layer, transport layer. Transport layer is going to perform segmentation, then transport layer will add TCP header, but you know it will not send the actual message directly. Source port, random port number, destination port 23, but it will not send this telnet request message. This telnet request message is on hold. Why?
TCP, three-way handshake.
Because it will establish control connection here with the help of three-way handshake. So PC1 is going to send SYN message to router 2, and in the SYN message source port, destination port 23, right? Here even it is not going to add the port number. Whatever port number it will use to establish the connection, that will be the port number in actual telnet request message. So SYN message, now server is going to generate SYN plus SYN plus ACK message, and in the SYN plus ACK message, source port number will be 23 and destination port number will be 1024. And then finally it is going to send, router 1 is going to send ACK message acknowledgement. And now we will have what? TCP connection here between router 1 and router 2. After that it will send this actual telnet request message. Telnet request message, right? Source port, the same port number which it has used for this TCP connection 1024, destination port 23, source IP 10.1.1.1, destination IP 10.1.1.2, source MAC address of R1 and destination MAC. Check ARP table. If it is not available in ARP table, then it will goes on hold and it will call to ARP protocol. ARP protocol will generate ARP request message. In the ARP request message, you have seen source or target IP 10.1.1.2, target MAC 000, right? And source MAC address of R1, destination MAC broadcast. So PC1 is going to send this ARP request message to router number 2. My God, ARP request to router number 2, and router 2 will generate ARP reply message. Reply message to router number 1. Router 1 will update their ARP table, and after that it will send actual telnet request message, and then your router number 2 is going to send what? Telnet reply message. This will be the complete packet flow. Now packet flow will be same for any protocol. For HTTP also it is going to be same, only destination port will be different. For SSH also it will be same. For UDP traffic, three-way handshake will not happen. Your process will start from here. ARP request, ARP reply, then actual request message and reply message. This is what? Packet flow. Now in next class, what we are going to discuss? These application layer protocols. Like, see what I told you about application layer protocols. You need to learn port number, what protocol it uses, a transport layer use for, and then that's it. HTTPS, telnet. So we will have lab on these all protocols. Here you need to test actually protocol packet flow for these all protocols, DHCP and DNS. These are the application layer protocols which we will cover tomorrow, and then I will come on Cisco iOS operating system.
Sir, I have like installed the GNST previously, but like whenever like my routers are working, but like I am not able to like access the like switches, like the CLI access.
Yes, in the GNS3 you cannot access switch. In GNS3 switches are non-manageable. These are non-manageable switches. So
Okay.
that's why I ask you to set up
EVNG.
AVNG.
Okay. Like I have set up EVNG as well, but like whenever like I try to like capture the packet from Wireshark,